So we have our three ways of writing a ratio. So let's take a look at the hearts here. It says, how is this, well, hold on, I'll get to that in a second. What is a ratio, if I asked you, of small to large? 3 to 6. Now, you won't see that. It's never going to be called a 3 to 6 ratio. It's going to be reduced just like we reduce a fraction. If we saw a fraction 3 over 6, what are we going to call that? 1 over 2. So we would call this a 1 to 2 ratio. Now, ratios can actually go either way. It's just whatever they ask you. I could ask you, what is the ratio from large to small heart? What would that be? Yeah, it would be 6 to 3, large to small, which reduces to 2 to 1. Now, the confusing thing is the scale factor. These actually have different scale factors. You remember K from your test, your final? The scale factor? What do I need to do to 1 to get 2? Remember, a scale factor is multiplication. So multiply it by 2. So I would say, if I'm giving you a ratio from small to large, the scale factor is 2. In other words, I need to double the size of the heart, right? But if it's the other way, it's not 2 anymore. If I tell you this from large to small is a scale factor of 2, it would be 4. So what do I need to do to the number 2 so that it's only a 1? I need to multiply it by 1/2. So it's how do you get to the image or to the second object? Remember that from your last test? Cool. Let's do this example. For every 2 boys in the classroom, there are 3 girls. So this is on your notes. Number 1, it says, what is the ratio of boys to girls? 2 boys to 3 girls. So your answer would be 2 to 3. But ratios can also go the other way. So what is the ratio from girls to boys?
3 to 2.
3 to 2. Now think about this one for a second. It says, if there are 12 boys, how many girls are there going to be? Now real quick, I'm going to draw a little visual for you. So for those of you so if it's a 2 boys to 3 girls. So here's boys. I like to kind of think of it as sections. So there's 2 groups of boys, right? And then girls, how many groups is there for every 2 boys? 3. Now, it's not necessarily 2 boys and 3 girls. It's not necessarily a class of 5, but it follows this ratio. So how many groups are the girls split into? 3. So for every 2 groups of boys, there's 3 groups of girls. So if we know that there are 12 boys, how many was in each group? 6. So basically, all of these groups are 6s. So Ryan, how many girls are there? 18. You kind of see how I common sense that out a little bit? Sometimes pictures, those visuals can help you kind of visualize what's happening. Let's say that there were 6 boys. There were 6 boys. How many is in each group? 3. So how many girls would there be? 9. So a 6 to 9 is a 2 to 3 ratio. Yeah?
Would there ever be odd numbers?
Yeah, that can be. Ratios are not always nice, pretty whole numbers either. So the question then says, how many total students are in this classroom? Not this classroom, this classroom. 30. 12 plus 18 means there's 30 students.
Oh, I thought we were going based off of
Based on the 2 to 3 ratio, if there's 12 boys, we know there's 18 girls, so 12 plus 18 is 30. Easy enough? All right. A 3-way ratio. What? I thought ratios were only 2 things. It can be 3, it could be 4, it could be 5. This is a 3-way ratio. 4 to 7 to 5. And it says this triangle has a perimeter of 96. So real quick, go ahead and draw a little triangle out to the side. It's always good to visualize what's happening here. I like to draw. how do I know that this is a scalene triangle? Obviously, I gave it to a picture of you, but let's say I didn't give you a picture. Tessa, how do I know that it's a scalene triangle?
Because all the numbers are different.
Yeah, all the numbers in the ratio are different. What would a isosceles ratio look like, Tessa?
The two numbers are the same.
Yeah, so like 4 to 4 to 7, or 2 to 2 to 3. So I'm going to label the shortest side with a 4. I'm going to label the longest side with a 7, and the medium side with a 5. Now what is 4 plus 7 plus 5? 16. That would be the perimeter of this triangle. But what do we need the perimeter to be?
96.
96. So we need to multiply all three sides by the same scale factor. We need to make all three sides bigger by the same amount. Okay? So let's set up a little algebra 1. What is perimeter? How do I find the perimeter of a triangle?
You add up the sides.
You add up all the sides. And what do we need it to be? 96. So we attach an x to tell us that we need to multiply it by some number. So go ahead and combine like terms, CLT on the left side. See if you can finish this off real quick. What is the left side condensed down to, or combine our like terms, and we get what? 16 x's. And then how do I undo 16 times x?
Divide.
A little division po. And what do we get?
6.
X equals 6. Now that's not my answer. It doesn't ask me what is the scale factor. But basically, this is basically your k. That's how much larger we need the triangle to be. 6 times larger. So if you take, which one's the shortest side, obviously? 4. And you multiply it by the scale factor we just found, how long is the shortest side? 24 centimeters. That is your final answer. How many of you got 24? The ratio of the angle measures, so we're in a different mode now. We're not talking about perimeter anymore. We're talking about the angle measures of a triangle is, bless you, 1 to 6 to 13. What is the measure of each angle? You should be able to do this on your own. So go ahead and give it a try. So if you haven't figured it out yet, what do the interior angles of a triangle add up to? 180. So x, 1x, plus 6x, plus 13x equals 180. Before we get 20 x's equals 180, divide by 20, x is 9. Is that your answer? No, you need to plug that back into the 3 angle measures. So we need to, basically our triangle is 9 times that ratio. So 1 times 9, 6 times 9, and 13 times 9 gives us 54, 9, and 117. And what should happen when you get those 3?
They add up 180.
They should add up to 180 if you did it right.
Wait, I'm so.
I'm going to kind of set this one up for you because there's one like it on your homework. So the perimeter of a rectangle is 42 inches. The ratio of width or length to width is length to width is 5 to 2.
Oh my god.
5 to 2. Okay? Once again, we're back to perimeter. How many sides of a rectangle are there, though?
4.
4. And what do we know about opposite sides of a rectangle?
The same.
They're the same. So, yes, we technically only have 2 numbers here, but if this is 5, then this is 5. And if this is 2, then this is 2. I know this isn't on your notes, I'm just showing you. Now, does 5 plus 5 plus 2 plus 2 add up to 42?
No.
No. So once again, we just need to attach an x to all 4 sides and set it equal to, what we need the perimeter to be, 42. And then just combine like terms, divide. Okay? All right. Now we're going to talk about proportions. The last thing for today, we're going to learn about proportions. Okay? A proportion is different than a ratio. It's two ratios that are set equal to each other. So we now have an equal sign. And do you remember what we do when we have a fraction equals a fraction? In middle school, what do you do? It's on the board. It's in a big tan rectangle you run over.
Cross.
Cross multiply. Okay? Now, let's think back real quickly. Let's look at the problem x over 2 equals 4. If you're back in, I don't know, 7th, 8th grade, how could you get x by itself if it's being divided by 2? Multiply the 2 to the top of the other side, right? So if I multiply both sides by 2, what cancels? The 2's go away, and basically the number that was down here gets multiplied to the top of the right side, and what's our answer? 8. So that's basically the concept behind cross multiplying. This number is going to get multiplied up to this number, and this number is going to get multiplied up to this number. Does that make sense? Okay, see if you can solve this problem real quick on your own. It should be pretty. This is not new. This is 8th grade. And then you just need to divide both sides by what? 56, right?
What? Why?
So you get 56x. So you divide both sides by 56.
What you just told us did not make any sense.
What do you mean it doesn't make any sense?
Like, that compared to what you just said did not make any sense. Exactly.
This times this is what?
56x.
56x. This times this is what? 504.
Wait, what?
What is 7 times 72, Kaylee? Put in your calculator. Okay, it's 504. How do you undo 56 times x? Divide both sides by 56. You guys, this is algebra 1. X equals 9. And go ahead and try this one on your own. A lot of it on your own today. This is a lot of algebra 1 review. This is stuff you should already know.
3x.
3x plus 4. If you're multiplying 2 by 2 things, you have to distribute. How many of you remembered to do that? 6x plus 8.
Me.
And now we're just back to some addition pose and subtraction pose. So I'm going to subtract 6 x's to the left. So how many x's do I have on the left side now? Negative 1 x's.
Divide by negative 1.
Divided by negative 1.
Equals
X is negative 8.
negative.
We have a room, and we have a scale, like a model of a room. Okay? So which one's obviously the bigger one? The one in feet or the one in inches? Yeah, those feet. So the room is 12.5 by 15. The model, bless you, is 5 by something. So we need to find the something. Okay? So what we're going to do, we're going to set up what we call a proportion. A fraction equals a fraction. So what are the dimensions of the actual real room? 12.5 by 15. So I'm going to put those on top of each other. Usually the two things that we know, I'll stack those on top of each other. 12.5 over 15. And what units are both of those in? Feet. I really wish, go ahead and attach feet onto there. It's 12 feet, or 12.5 feet by 15 feet. Now, the way you line this up, it has to go together. So if the width of the room is on the top of the right side, the width of the model has to be on the top of the left side. It has to line up. So what am I trying to find here? The length of the room in, what was the room in what measurements? Inches. So these are in inches. These are in feet. And that's okay.